there, Math Hoppers. In this video lesson, we are going to learn how to apply the distributive property. Let's start by thinking about 4 times 56. So when you see two numbers separated by parentheses, remember this is multiplication, 4 times 56. And how can we break up or rewrite part of this to make it easier to compute? Well, 4 is a single-digit number, fairly simple, not going to get any easier, so let's work on 56. If we rewrite 56 as 50 plus 6, we can use the distributive property to make the multiplication simpler. And here's what I mean. If we rewrite it, we'll rewrite 4 times the quantity 50 plus 6, where we put 50 plus 6 in the parentheses. Looking at what we used to have, we had 4 times 56. There was 56 inside the parentheses. We still have 56 inside the parentheses. So these are equivalent. But what I really like about this is it shows the importance or the need to multiply 4 times 50 and 4 times 6. If you only multiplied 4 times 50 and then added the 6, you would not be doing 4 times 56. And that's the key to the distributive property. It says everything in this parentheses gets 4 multiplied to it. So the 4 has to be distributed to both 50 and 6. And with this kind of an example, you can see why. So let's remember, when you are distributing, whatever is on the outside of the parentheses has to be multiplied to everything within the parentheses, both terms within the parentheses. So what I want to see is 2 arrows. If you're going to multiply 4 times 50 and 4 times 6, I should see an arrow from 4 to 50 and from 4 to 6. And how is this easier? Well, we now see that the product of 4 and 56 is the same as saying the product of 4 times 50 plus the product of 4 times 6. 4 times 5 is 20, so that makes 4 times 50 pretty easy to do, and we should already know 4 times 6. So we get 200 plus 24. The product of 4 and 56 is 224. And that's all well and good, but this is algebra, so we know variables are going to be involved. So let's really get into the distributive property. Let's use a visual model, and I want you to picture a rectangle with a height of 5 and a length of x plus 3. So something like this. And I have a little dashed line there because we don't know the entire base. We know portion of it is 3 and the whole base is x more than 3. So if I wanted to take the entire area of this rectangle, the area of a rectangle is base times height, or length times width, however you think about it, we would do 5 times the quantity x plus 3. And we'd have to do the entire quantity because we need to include the entire base. So if we want to look at this visually rather than work with it algebraically, let's do that. Let's break this up into 2 rectangles. Let's say we know that the portion of the base over here in yellow is 3. So we know this portion of the base has a length of 3, making this portion our unknown length. We know the height is 5. So let's break this up into a blue rectangle and a yellow rectangle. If we do that, we have 2 rectangles. We can still get the area of the entire rectangle by simply considering the blue rectangle's area plus the yellow rectangle's area. So we have an area here. We have a rectangle with a base of x and a height of 5. And we have a rectangle with a base of 3 and a height of 5. So when we want to find the area of the blue rectangle, we do 5 times x. And the area of the yellow rectangle is 5 times 3, giving us a complete area of 5x plus 15. All right, enough visual models. Let's see what we're going to do on pencil and paper when we get these problems algebraically. We have 2 times the quantity x plus 4. So what we're going to do is make sure that we are multiplying this 2 to everything within the parentheses. That includes x and 4. So I should see 2 arrows. 2 times x plus 2 times 4. So it is the sum of both products. You are simply saying I'm going to multiply 2 and x and 2 and 4, and then you are going to add those products. We get 2x plus 8, and that's it. Remember, you can only add like terms. We cannot simplify this any further. All right, does anything change if the value being distributed is on the right-hand side? Answer, no. It doesn't change anything that you do. It doesn't change the order in which you have to do these. You may multiply them in a different order, but you don't have to. You still have to make sure that you multiply 3 times 5 and 3 times x and add the products. So 3 times 5 plus 3 times x is 15 plus 3x. Now, could you have written 3x plus 15? Because I know generally we like to see our x term or a variable term on the left-hand side. Absolutely, you could have. Does not matter. Commutative property of addition isn't really what's being applied here because they're not like terms. You can't add them. Just know that 15 plus 3x is the same as 3x plus 15. So now let's practice where we really mess these up. When we distribute a negative, we oftentimes forget to take that negative. If you see a negative sign in front of the value being distributed, so in front of the number outside the parentheses, you got to grab it. You are taking that entire -4 and distributing it to n plus 2. So -4 times n plus -4 times 2. Now, could I have just written -4n minus 4 times 2? Yes, it gets a little dodgy. People don't like to think of this as being a negative, but it's not anything other than a negative. It's not a floating negative sign or a floating subtraction sign. So I really want you to think of this as a -4 being multiplied to n and then being multiplied to 2 and then taking the sum of those products. So you get -4n minus 8. -4 times n, unlike signs, is negative. -4 times 2, unlike signs, is negative. Let's look at another one where the negative is on the right-hand side. Again, nothing has changed. Now, when you see these, sometimes you'll see them put this negative in parentheses where they didn't over here. It doesn't change anything. It has nothing to do with order of operations. It just makes it look neater. It's like they said, okay, not only is this negative, it's also on the right-hand side. It kind of looks like a hot mess. Let's try to clean it up for you. And they throw it into a parentheses. It still means distribute -3 to the 6 and -3 to the x. So you still have to do -3 times 6 plus -3 times x, or -18 minus 3x. All right, now what if we distribute over subtraction? So now the value out here is positive, but we have a minus 7 within the parentheses. So when we distribute, we can think of this a few ways. You can say, I'm going to multiply 5 times a, bring down my subtraction sign, and multiply 5 times 7. That's okay. Oftentimes, though, the subtraction sign does get forgotten. So I want you to think of it this way. 5 times a, and then look at your signs. This is a 5, this is a -7. We can think of this as a plus -7. So if we say 5 times a, and then 5 times -7, and we add those products, we will not forget our sign. So 5 times a plus 5 times -7 gives us 5a minus 35. Looking at a similar problem, this time we're going to distribute over subtraction, and what we're distributing is negative, and it's on the right-hand side. Still, nothing has changed. We are going to take -8, distribute it to both terms, x and -4, or x and -4, and we are going to make sure to watch our signs. -8 times -4, -8 times x, and you are going to combine those two products. So we get negative times negative is positive, negative times positive is negative. We get 32 minus 8x. Now, can we write this with the x term on the left-hand side? Absolutely, but be careful. You need to include that sign. 8x is negative. If you move it to the left, it still needs to be -8x. So here are the rules. When we distribute a times the quantity b plus c, we are simply doing a times b plus a times c. Pretty easy. We saw lots of examples like that. 4 times the quantity n plus 3 is 4n plus 12. If we throw the a, the thing being distributed on the right side, it doesn't change at all. I mean, they wrote it differently, right? This now says b times a plus c times a, but we know these are equivalent. And we saw examples of that. The quantity n plus 2 times 3 is still 3n plus 6. 3 times n plus 3 times 2. Now let's look at distributing over subtraction. So if we have a times the quantity b minus c, you are going to take the difference of the products. Or you can think of this as a times b plus a times -c. Either way. We saw examples. 2 times the quantity x minus 8 would give you 2x. minus 16. So 2x minus 2 times 8, or 2 times x plus 2 times negative 8. Remember, plus a negative, we just write minus 16. If we throw that on the right-hand side, does anything change? Absolutely not. The quantity b minus c times a is ba minus ca, or this is exactly equivalent to ab minus ac. We saw examples of that. The quantity x minus 5 times 7 can be thought of as 7x plus 7 times negative 5, or 7x minus 7 times 5. All right, let's look at some more that really throw us, and that's when we have an expression that is a little more involved, and we have distribution within the middle of it. When you have distribution in the middle of an expression, that distribution comes first. You distribute first. Think about order of operations. You always did parentheses or brackets first. That's what distribution is. So when we have 8x minus 3 times the quantity 2x plus 1 plus 8, we are going to distribute first. What's the most important thing to remember? Grab that negative in front of that 3. Don't simply say 3 times 2x, 3 times 1. You will lose this subtraction sign if that's how you're thinking of it. Grab the entire negative 3 and distribute it. So negative 3 times 2x, negative 3 times 1. Cleaning everything up, we get, let's see, 8x just came down. We didn't do anything with that, right? So we get negative 3 times 2x plus negative 3 times 1. And remember, the 8x and the 8 just came down. We hadn't done anything with it yet. So cleaning this up, negative 3 times 2x is negative 6x. Negative 3 times 1 is negative 3. Let's see what that looks like. Okay, where did those two terms come from? Remember, negative 6x came from negative 3 times 2x. The negative 3 came from negative 3 times 1. 8x and 8 just came along for the ride. Now we're going to clean up by combining like terms. I can subtract 8x minus 6x. If I have 8 x's and someone takes 6 x's from me, I have 2 x's left, right? So I have 2x minus 3 plus 8. Now we're going to clean up. Negative 3 plus 8 is positive 5, so we get 2x plus 5. All right, let's do one more. This one looks very similar. We have an expression. We have to distribute in the middle of it. So let's go ahead and do that. Let's grab that negative 4x. We're going to distribute it to both x and negative 3. Don't lose that negative 3. Don't think, oh, I'll just bring down my subtraction sign. You may forget. Let's distribute negative 4x times x, remembering that x times x is x squared, and negative 4x times negative 3. Let's bring it all down and see what we got. Okay, so the 5x squared and the 5x just came down. We didn't do anything. And then when we distributed negative 4x and x, we got negative 4x times x plus negative 4x times negative 3. We didn't lose any negative signs. Now let's clean it up, because let's be honest, that's a hot mess. So 5x squared and 5x again are going to stay the same. Cleaning up these terms, I get negative or minus 4x squared. Negative 4x times negative 3 is positive 12x. Remember, 5x and 5x squared just came along for the ride. Let's clean up our like terms. We have 2x squared terms that we can combine, and we have 2x terms that we can combine. So 5x squared. Let's say I have 5x squareds. You take 4x squareds from me. I have 1x squared left. If I have 12 x's and you give me 5 x's, I now have 17 x's. I have x squared plus 17x. That is the distributive property. I know it is the bane of our existence. If you're working through stuff in class or studying for a test or maybe doing a quiz in this module and you see something you're just not getting or you don't know how to set it up, you should be subscribed to our YouTube channel. It literally exists for you to send all of the problems that you cannot complete or are confused on in. We will make you a custom video solution. It will help you out. You will feel so much better about your math homework. And that's the whole point of it. I really don't know where else I was going with that. All right, until next time, Math Hoppers, take it easy.